Read the question carefully. In part A, we are asked to determine the average velocity over this time interval, and the formula for average velocity is given by just rise over run. Okay, that's the slope of secant line, the run between 2 and 5, so 5 minus 2, and corresponding displacements are given by this formula here. So we need to, let me write down, this is displacement at 5 minus the displacement at 2. So this is rise and this is run, okay, over 2 5. Now next, this is 3 on the bottom, 5 minus 2. As at 5 means we need to evaluate this position function or displacement function at 5. So basically plug in 5. So 5 cube 25 minus 2 times 5 10. Sorry, 5 cube is 125 and 2 times 5 is 10. So 115 minus the position at 2, as at 2, plug in 2 here, 2 cubed 8 minus 2 times 2 4, 8 minus 4 is 4, okay, which is 115 minus 4 is 111 over 3. Let's try to divide, and it divides, it goes 3 times 3, 37, and this velocity is, it's a feet per second, but it's given in meters, so we need to write meters per second. Okay. In part B, we need to find the instantaneous velocity at t equals 2. So at this particular time t equals 2, what is the instantaneous velocity? If we read this question more, then we find this prime notation, that's the derivative or rate of change, and from this the rate of change is the velocity in fact. Okay, so we just evaluate this first derivative at t equals 2. So instantaneous velocity at t equals 2 is just here, derivative at 2. So plug in 2 here, so 3 times 2 is square, 3 times 2 is square, 4, 3 times 4, 12 minus 2, 10, just 10, and it will be meters per second as well because it's velocity like part A. In C, we need to find the acceleration of this particle when t equals 3. So acceleration means it reverts to second derivative, and that is also given in the question. So we use this formula to determine the acceleration. So acceleration at 3 when time is 3 equals, just plug in 3, 6 times 3, 18, and it will be meters per second. So meters per second is square. Final.